Hello guys, welcome back to my YouTube channel, and my name is Dharyll, and here in our video we're going to tackle about chapter 7 and answer some activities on this chapter. So this chapter entitled IP addressing. So IP addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of the whatever the hosts are on the same network or on different networks. So IP addressing is very important to ensure the connection between two devices or two networks or hosts to a network. So without further ado, let's get started the activities here for more ideas and for better understanding. So here in our first activity, which entitled binary to decimal conversion. So this the instruction here is this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you pick with this tool until you are able to convert without error. Convert the binary number shown in the octet to its decimal value. So in this activity, uh, we were going to disregard the base and exponent. So what is important here is the position and the bit. So the easiest way that I know to answer this activity is you're going to disregard the value uh, of 0. So for example, here this is 0, and the value of this 0 in, in upward is 128. So we will disregard that, and it is not counted. But if it is the bit is 1 and upward it is a 6, upward the value of it is 64, so we will include this. So that is the trick, and I hope you get it. So let's try to answer this. But before I proceed, since this is the in this example only here is 1, so the answer will be 64 since all of the bit here is 0. So we will disregard all of it because it is 0. So the only we will compute is 1, which is upward is 64. So the answer here should be 64. So let's try another problem here. Here. So this is 1, 1, 1, 1. So like I said a while ago, we will disregard all the 0 and the value upward. So what we are going to consider here is only 128, 64, 16, and 4 since they have 1 in bit. So in order to answer this activity faster, we'll use a calculator. So 128 plus 64 plus 16 and 4, so equals 212. So the answer will be 212. So that is the correct answer. So lastly, let's try some new problems here. So here, disregard all the 0. So this part in the middle part will not be considered in computation since it is 0. So this is 1, 1, 1, 1, 1. So what we are going to compute here is 128 plus 64 plus 4 plus 2 plus 2 and plus 1. So it's 199. So it is correct. So that's how you uh, convert decimal. So, sorry, to convert binary to decimal. So let's proceed to the next activity, which entitled decimal to binary conversion activity. So here in this activity, it is seems like the previous activity that we answered before, but the difference here is now we are going to we are going to convert the decimal to binary. So in this activity, decimal is given, but the binary is that is we're going to figure it out on how to answer it. First, let's read the instruction. This activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do conversion without error. Convert the decimal number shown in the decimal value row to its binary bits. So here, let's start to answer this activity. So the decimal value that we have here is 244. So since it is bigger to 128, we will put 1 here. So we need that in our computation in order to reach the value 244. So for better understanding, I will show you my calculator. Since we include 128, and then let's try to subtract it to the decimal value that is given. So 128 minus 244 is equals to 116. So that is the value that we need to find in order to reach the value 244. So we need, so 116 uh, is greater than 64. So 64 is included still. So we're going to subtract 64 to 116. So 116 minus 64. So the value that we still need to reach is 52. So 52 is greater than 32. So we will include it to our computation. I'm so sorry. We will include it to our computation rather. So 52 minus 32 equals 20. So 20 is greater than 16. So we're still going to include 16 to our computation, and we will put number 1 if we want to include it to our computation. But if we're not like to include it to the computation, we're going just to put 0 0. But since we need it to acquire the value 244, we need to put 1 here. Here 20 minus 16 is obviously 4. So 4 is less than 8. So it is not possible that we need 8. And since the last value that we need is 4, we're just going to include 4 and disregard all, and we put 0. So that is my trick or technique on how to convert decimal to binary. So let's check if we got the correct answer. So that's it. We got the correct answer, and let's try another problem to answer. Here we are given 23. Since it is not a large number, we can answer it mentally. So with this regard, 23 is not greater than 128. So that's 0. 64 also is not possible. 32, 16, 16 is less than 23. So we need this value. So we have 16 in our computation, and 16 plus 8 will be 24. So it is not included. 16 plus 4 will be 20. So we just need 3 more, and 4 will be included to our computation, since it will not go over 23 value. So 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 far we have 16 and 4, and when we add that we have 20. Since our goal is 23, we need 3 more to reach the decimal 23. So 2, let's just remember that we have the 20 now. So the value 2 will be needed, and also 1 to acquire 23. So we will put 1 and 1 here. So that's it. So, and let's try for the last time. So 60, 128 is greater than 60, so it is not included to our computation. 64 is greater than 60, so it is not, still not. 32 is less than 60, so it is included to our computation. So we have now 32, and we still have to look 28 more to acquire 60. So 32 plus 16, 32 plus 16 will be 48. So we're still good to go. We will include 16 to our computation. So 48, that will be 48, and then 48 minus 60 will be 12. So the last value that we need to acquire is 12. So let's find two numbers here. When we add, will be, the answer will be 12. So 8 plus 4 will be 12. So 2 plus 1 is not possibly going to answer 12. So we will put 0 here. So 8 and 4 will be needed to our computation to acquire the decimal value 60. So let's check. So that's it. We got the correct answer, and that's my technique or trick on how to convert the decimal to binary. So let's proceed to next activity, which entitled ANDing to determine the network addresses. So address rather. So the instructions here is use the AND process to determine the network addresses in binary and decimal format. So here, the trick here is we're just going to look in the host address in binary and subnet mask in binary. So in answering this activity, we're just going to align each number here, and then if it is in alignment, when there is a 0, so it will be 0. But in an alignment there is a 2 1, you should write 1. So if it is 1 0, it is 0, 0 1, it is 0, 1 1, it is 0. So here in this problem, the first alignment is 0 1, so that is 0. Second alignment is 0 1, that is also 0. Third alignment is 0 0 1, that is also 0. Fourth alignment is 0 also. Third is fifth will be 1. Sixth alignment 0. Seventh alignment will be 1. and the final alignment will be 0. So next, we will just repeat the process until you reach until the end. So 0, 1, 2, 3, 4, 5, 2, 3, 4, 5, then 2, 1, then 0, then 1, 2, 3, 1, 2, 3, 4. So we have 1, 2, 3, 4, 1, 4, 1, then 0, 0, 0, and 0. Next will be 0, 0, 0, 0, 0, 0, 0, 0. All of it will be 0. So in network address in decimal, we're just going to convert this binary to decimal. So when in this instance, which our network address in binary is uh, has the same binary as the host address in binary, so their value will be 10. Here also, has the same binary and in the host address binary. As you can see, it is the same. So their host address or decimal value should be here, the host in the host address. So 6. And the next also here in this instance, so we don't have the same binary in host address in network address. So what we are going to do here is we're just going to manually compute the decimal value of this binary. So the trick in answering this in this activity is, let's assume that for example, we have a 8-bit binary. So let's go back here to the previous activity. So since it is 8-bit, so here is the value of the position of the 8-bit binary: 128, 64, 32, 16, 8, 4, 2, 1. So you just need to memorize this position in the 8-bit binary. Here we have here the 8-bit binary, and we were just going to add the computation of those who have one binary. So for example, in this situation, we have 1, 1, 1, 1, 4, 1, and then 4, 4, 0. So just like in the first activity, we will just include the value 1 in our computation. So let's go return here. So the value that we were going to include to our computation will be 128, and in the next one will be 64, and then 32, and then 16. So the decimal value here will be 240. So in the next network address in binary, so since it is all 0, so we were not going to compute here or convert it to decimal. So we're just going to put here 0. So I hope I got all the correct. Let's check. So that's it. We got the right answer here in this activity. So let's try answering another problem. So here we have 0, 1 in the first alignment. So 0, 1 will be 0. Second alignment is just like also 0, 1. Alignment 1 until alignment 4 will be 0, 1. So the answer will be 4, 0. Then in the fifth alignment there's is both are them is 1. Just go with 1. So 6 alignments, 0, 0, 1, 0, 1, then 0. Next will be 0, 1, 1, 1, then 1, 2, 3, 4. This all 0, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 0, 0, 0, 0, 0, 0, 0. All of them will be 0. So here we're going to, let's check. First, we're going to check if the network address in binary and the host address in binary is the same. So here, in this instance, they are the same. So the value will be, you will copy the host address here. So 10. Next is, will be 1, 2, 3, 4, 1, 2, 3, 4. Sorry guys, my eyes is a little bit irritated. I'm so sorry. There will be 4, 1 here. 1, 1, 2. Yeah, there will be a 4, 1 here. So we're just going to convert it to binary. So since the first value is 0, we will not include 128 and we're going to start to 64 plus wait. So here in this instance, it is also the same as the host address in binary. So our expected network address in decimal should be 120. So let's check if it is really 120. So plus 32 plus 16, then plus 8. So it's 120. So the answer is 120. So it is really when the network address in binary and host address is the same, they have also the same host addresses. So we're just going to copy 120. So since it is 0, 0, there is no value, and 0. Here in this instance, since it is the first value is 1, then the rest is 0, then we all know that in the first value is 1, the position will be 128. So 128 will be the answer here. That's it. We got all correct. So let's proceed to the next activity. So which is unicast, broadcast, or multicast. So the instruction here is click start to view the destination IP address. Next, click the host which will receive the packet based on the address type. Unicast, broadcast, or multicast. This is a timed activity. So we're just going to identify where will they be the packet is the corresponding destination. So let's press start. 237 237 So it is a multicast type. So you have successfully identified the transmission type. So let's try another. 255.126 2551. So it is also a So it is also a sample of unicast IP address. Let's try another. Oh, it is the same as the last the IP address. Let's try the different IP address. So here, so it is a unicast type of IP address. So next, so this is a multicast type of IP address, since there is a 255 in the end. So that is how you will identify the unicast, broadcast, or multicast IP address. You're just going to look at their corresponding IP address, and then you're going to identify it by yourself. So the next activity will be public or private IPv4 address. So here in this activity, we're going to uh, choose which is the public type address and the private type. So public type address, which commonly connected to the internet, and the private IP address is mainly used on the industries, for example in the office, which they have their own IP address which will not be brought to the internet. So for more understanding, there is a specific range of the IP address which is private. So here are the range of the IP private IPv4 address. So it is 192, that's 168. So this is the range, which is also included here in the net. It is they display here the range of the private IP address. So without further ado, let's get started this activity. So here we can see that it is within the range of the private IP. Next is 192.168, so it is still unprivate. Next is 192.0, so it is a public. And 64.104, it is not in the private range, so it is a public. So 209.165, it is not also in the private range, so it should be public. Next is 192.168. 192.168 is in the range of the private IP address. Next is 172.16. 172.16, so it is in the range of the private address. Next will be 10.55. So 10.55.3 is not in range of the private address, so it should be public. So I hope I got all of the correct answers. So let's go check it. Oh, I forgot this. So the 168 here is the range of also of a private IP address. Here it should be here in the range of the 10.00. I'm so sorry. So that is a private address. So that's it for this activity. So let's proceed to the next activity. So here in this activity, it's just a slight, it is slight confusing, but you can answer it when you know how to, the technique on how to answer this. So first here, we're just going to copy the preferred format to the image leading zeros. Should be 2001, then 0000. Here we, I'm so sorry, we're just going to include 0. Here we're not going to count the 0. So we're going to start with DBA, then 1111 0 0 0 0 sorry, 0 0 0, and then 0. Now we were going to compress it to, so what we're going to do, 1, then colon, and then 0 colon, then DB8 colon, then 1111 colon, and then colon. So we managed to answer the first number 1 activity. Next, let's proceed to number 2. Let's until we reach the number 10. So just like in the first number, we're just going to copy here, then 0. We disregard the first 0, and we're just going to copy 1 2 3 and 4 5 6 7 8 9, then AB, C D E F, then 0. Then we disregard all of the 0 before the first number. So 1. So here, then 2 or 3, then semicolon. We're just going to divide it by a semicolon. And then 0 semicolon 1 2 3. 1 2 3, then 4 5 6 5 6 4 5 6 7, and then 8 9 AB, and then C D E F, and then 1. So we managed to answer the number 2. Then the next number will be 0 0 0 0 0 0 0. Then we disregard the 3 zeros and we put 1. Then the compressed format will be double colon, then 1. So that's it for the number 3. Number 4 will be, we're just going to copy the preferred format here, A B C D E F 0 1 2 3 4 5, and 0 6 7 8. Oh, I forgot, so we need to disregard the 0 6 7 8, and 9 10 1 2 3 4, and 1 2 3 4. So the compressed format will be 12 semicolon A B C D semicolon, and F 0 1 semicolon 2 3 4 5 semicolon, then 7 8 semicolon 9 10 semicolon A semicolon, and B. So that is for the number 5. And for the number 5 activity, we're going just to copy again AB 1E, then 2 2B 0 0, then 0, then 1 2 3 4, then 5 6 7 8, then 9 1 0 1, then 1 1 1 2, and 1 1 1 3. So the compressed format will be A B1E semicolon I colon to B00, then double colon 1 2 3 4 semicolon 5 6 7 8 semicolon 9101 semicolon 1112 semicolon 1113. So let's go proceed to number 6, and BBB2 B EF 12 and B FF3 and 9125 1111 and 0101. Let's disregard the first zero, then 1111, then 010. Let's disregard the first zero again, then 010. So the compressed format will be BB 2B and EF12 and BFF3 and 9125, then 1111 and 101 and 1111, then 101. So let's proceed to the next number. We're just going to copy the preferred format to the emit leading zone 1 2 1 1 2 9 and 1984 2 2 3 3, then 4 4 5 5 6 6 6 7 7 0 0 and 101. So the compressed format will be 1129 1984 2233, then 4455 6677, then 101, no, 67, then 101. So that's it. So next, number 8 is going to copy 0 0 0 0 0 101 and 111. Here the compressed format will be 111, then semicolon 101 colon, then 1111. So the next number, just copy again the preferred format, then 1976 1 2 3 4 0, then 101. So the compressed format will be 1031 year and 1976 colon 1 colon 2 colon 3 and colon 4, then double colon 101. So then let's proceed to number 10. So this is 0 0 0 and 134 134, then 6678, then 9101 0 and 3 4 AB. So the compressed format will be double colon 1 2 3 4 semicolon 6 6 8 7 8 colon 9101 colon, then 0 colon, then 3 4 AB. So that's how you convert IPv6 to its compressed format. So let's proceed to the next activity, which will be the configuration of uh, the switch or the router. So here in this activity, we'll just configure and activate the following interfaces. So in order to do that, we need to type the interface IPv6 gigabit gigabit ethernet gigabit ethernet 0/0. Then we will assign the IPv6 address. So our IPv6 address here will be 211 semicolon, then BBA colon, and ABCD colon 1, and slash and 1/64. So after we type that, we need to type the command, no shutdown command. So the next thing we need to do is to just repeat the command, which interface gigabit gigabit ethernet 0/1. Then we're going to assign the IPv6 address to 110, then BB8, then AB AC AB, then 2, then double semicolon, and 1/64. So let's repeat it again. 1v6. I forgot to input the address. Then 21 the BB8 ACAD, then 2, then double colon, and 1/64. Then the no shutdown command. And next we're going to do is the interface serial 0/0/0 IPv6, then address will be 2110 colon BB8 colon ACAD, then colon 3, then double colon 1/64. Then the no shutdown command. Now we managed to configure and activate the following interfaces. So let's proceed to the next activity. So here, what we are going to do here is to IPv6 address configuration. So we're going to first show the IPv interface brief. So we're going to type show IPv6 interface So this command displays the abbreviated output for each of the other interfaces. So this is the abbreviated output, which the up/up in every interfaces. So the next command that you'll type is the show IPv6 root, and then when you type that command, it will command can be used to verify that IPv6 networks and specific IPv6 interfaces addresses have been installed in the IPv6 routing table. So this is the one that will ensure that your IPv6 network and IPv6 interface addresses is properly installed in the routing table. So the last thing we need to do to verify the connectivity to the PC is we're going to ping the IPv6 IP address, which is DB8, then ACAD colon 1 then 10. So when you that's it, by verifying the connectivity, you're just going to ping and then type the IPv6 IP address of the specific network or host that we like to test the connectivity. So that's it for today's video. So if you like it, please subscribe, and there will be more videos that will tackle all about the NetAcad and different chapters. So I hope you like it. Thank you for watching.